Welcome back to Talent in America, ladies and gentlemen. This evening we've got the very own Chad Quivers, American freestyle champion and park legend. Why don't you come on out for us tonight, Chad? Welcome to the show.
Oh. How you doing?
What's up, Chad? It's nice to have you. So, Chad, what is your favorite part about freestyle skiing?
Oh, that's a tough one, man. Probably torn between lines, sends, and hucks.
Okay, interesting. So, Chad, if you could change one thing about freestyle skiing, what would that be?
Well, man, honestly, lately I've just been eyeballing all my runs. You know, like I don't have any numbers about how fast I'm ripping, how high I'm getting, how hard I'm tilting and shit. You know.
Chad, family show, please.
Ah, my bad.
Again, Chad, family show, please try and dial that in here.
You're right.
So some sort of data returns on how you're skiing, if you will?
Yeah, like I said, I've just been going off of vibes, eyeballing. Like I don't really have an idea how high I'm getting, how hard I'm sending, you know?
Yeah.
So.
Yeah, that's very interesting. So Chad, where's your favorite place been to ski?
Really, man? You asking me that right now? I told you I'm not going to answer that question.
Yeah.
Seriously.
I'm sorry,
why are you asking this type of question to me, man?
I thought
I was here for an interview.
I was just curious. That was one of the interview
All
questions.
right, man,
Chad, please, Chad.
I'm out of here.
I'm sorry if I offended you or anything. I'm really upset about it. I'm sorry. It's a personal question. I get it.
I'm out of here, man.
Chad, please.
No.
We paid good money for this time.
That was it.
Jesus, Chad.
That was it.
We are now back in the studio, and despite my awkward and unfortunate end to my interview with Chad, I believe my team and I may have picked up on a potential market via Chad's gripes with freestyle skiing. It seems that he, along with many other freestyle skiers, would benefit from some sort of device that has the ability to return data on how you're skiing. This sort of device could potentially track jump height, tilt, acceleration, rotation, and many other metrics. I'm going to take this concept to some of my buddies, and we're going to see what we can do. So after a lot of careful planning, building, coding, and wiring, we finalized the following design, which consists of 2 sensors and 1 actuator. An ultrasonic distance sensor mounted to the ski boot provides metrics on jump height, which in turn yields jump time. Getting the sensor to actually fit on the boot required a bit of careful design and 3D printing. An accelerometer gyroscope in the backpack returns data on acceleration, speed, rotation, and tilt. These values are outputted on an LCD mounted to the skier's arm for easy access. The wires discreetly run through the jacket and the backpack. Now let's go see the product in action. So if we go ahead and take a look at Cody's LCD before he jumps, we see his live height, 0.13 meters, and max jump height is 0, as he hasn't jumped yet. But if Cody lifts up his leg in a way to sort of simulate a jump, we see a new max height value is outputted, 0.65 meters. Using the Millis function, we can keep track of jump time as well. Once Cody reaches a certain height above the ground, the Millis function start time is recorded, and once the height drops back down, the end time is recorded. Using these 2 values, we can output both live jump time as well as final jump time. In this test, Cody had his ski above the ground for about 10 seconds, thus we see 10.86 on the LCD. The accelerometer portion of the gyroscope accelerometer allows us to output both speed and acceleration. In this clip, we see if Cody starts to shake his arm around, his acceleration value will increase. His max acceleration value is also recorded. When Cody starts to ski down the hill, his live and max speed are both outputted to the LCD. While this device technically worked here, it is a little difficult to really observe the values because the hill is so small. The gyroscope portion of the gyroscope accelerometer can return values on both tilt and rotation. In this clip, we see if Cody throws a few tilts, his live and max tilt values are outputted. This could prove to be very useful for someone working on upright carving. Live and max rotation are also outputted. Here, Cody's angle starts at about negative 60 degrees and winds up at about 260. This could be useful for someone working on rotation-based tricks, like 360s. Now, let's take a closer look at how all this works.
Alright, this is the wiring diagram. So we got the Arduino Uno here. It is powered by a 9-volt battery. The MPU 6050 is the accelerometer gyroscope. So it has its voltage and ground pins, and then also the 2 pins that actually send and receive data, which go into the analog inputs of the Arduino Uno. We have a button here that's connected to another ground, and that just its data is put into pin 3, so the Arduino knows when the button is pressed. There's an ultrasonic sensor here, connected to common ground and common 5-volt, but also both its pins are connected in a pulse width modulation pins in the Arduino Uno, so it can send and receive and figure out distances. Potentiometer here, connected to everything to the LCD, common voltage, common ground. This just controls the brightness of the LCD. And then we got the monster, the LCD here. So basically all these pins through over here and even down here are just for putting data on the screen and wiping the screen and sending commands to the LCD. But it's also connected to various common grounds and various 5 volts. But yeah, that's about it. It's pretty simple. And yeah, it looks like a mess though. Alright, this is the code for our awesome ski tracker. So as you can see, made by me, Michael, and Cody. So first we add the library for the LCD and its pins. We also add the button variables, and we also have a thing that tracks how long the loop is executing. This is just for to calculate a time step. These are the MPU 6050 libraries, which is the accelerometer. Tracking tells us and tells the LCD what to display. This is acceleration data, speed data, height data, time data, distance data, rotation data. This is just pi, and tilt data. These are the libraries for the ultrasonic sensor and their respective pins. This is height data and recording if you're off the ground. This is more jump. This tracks like jump start, jump time, jump speed, etc. These are calibration values that will filter gravity out of acceleration so that when the MPU's at rest, it says 0. And then these two values here are for tracking whether, are for calculating the time step of the loop. So we begin by setting up the intro screen and calibrating the push button and the serial monitor for debugging purposes. Then we connect to the MPU 50 here, or the MPU 6050 here. This is taken directly from their website. And we also set the range of what it's going to read. So it's reading 8G, 500 degrees, and 21 hertz right now. Now we get to the loop. The start time T here is just for tracking the time step, so this isn't really important now. These two are important though. These get the acceleration gyroscopic values from the MPU, and then this is just recording the gyroscopic values. We put those in a matrix here, and this was made by ChatGPT. I spent a long time in the library trying to figure out how to get gravity out of our acceleration. So ChatGPT came up with some magic as per usual. So we put the gyroscopic values in a matrix, and then we update that matrix with the correct orientation, and then we update the calibration values based on that orientation, and that'll remove gravity from the acceleration. And more on that down later where these functions are actually defined. This takes the acceleration of x, y, and z and calculates the magnitude of it. And then this is saying if acceleration is less than 0.1, it's just 0. It's a low-pass filter because when the thing's standing still, it's going to read stuff, so we're just kind of filtering that out. And then this is saying if acceleration is greater than the max, update the max to be it. Right here, we're calculating the speed in the x, y, and z, and then we're updating the magnitude of that speed. And then this is saying if the acceleration is 0, the speed is 0, because realistically, if we're moving, it's always going to calculate acceleration, and we don't want speed to go into infinity. So we're going to assume if acceleration is 0, it's at rest, we're not moving. This updates the max speed. This is calculating the rotation from around the z-axis based on gyroscope angular velocity and acceleration. And then also calculating the max rotation. Same thing here, we're calculating the tilt, max tilt. This is getting the distance off the ground from the ultrasonic sensor. And this is basically saying if the skier was not on the ground and they just got recorded like jumping into the air, so they're just starting their jump, set recording to true, record the start of the jump in time, and record the speed that we're going at. This is saying now we're recording, so now the skier's in the air, record the time, the current distance we're calculating, and update with the new height and the max height as well. This is saying if the skier now lands on the ground, get the final time, get the final distance, set recording to false, and set all the current height and jump stuff to 0. This gets the previous state of the button, and then puts that button into, this gets the previous state of the button, this gets the current state of the button, and then puts it into my press function, which basically just returns true if the button is pressed. More on that down below. But this will update tracking by 1. So the number tracking corresponds to what data the LCD displays, and then if tracking equals 8, which just basically means nothing, we set it back to 0, so it at least displays something. So if tracking is 0, we display acceleration to the LCD. If it's 1, we display speed data. If it's 2, we display height data. If it's 3, we display tracking data. If it's 4, we display distance data. If it's 5, we display rotation data. If it's 6, we display tilt data. And then if it's 7, we have something special. So it's going to record start a timer here, and basically check if the user presses a button within 4 seconds. If they don't press the button within 4 seconds, all the max values are reset, so the skier can track again. If they do, it'll just cycle through again. So this is saying if the timer hasn't started, start the timer. Ask the skier if they want to cycle or not. This is saying if the timer is started, see how many seconds have passed, and then if seconds passing has reached 4,000 or greater, which is 4 seconds, make all the max values 0, and then go back to showing acceleration here. Let's see where I'm at. And then this is just calculating the time step again. Here's the press function that I was talking about earlier. So it just basically reads the button state, and if the button has been pressed, return true, otherwise false. This is the clear LCD function, so it just clears the LCD screen to rewrite other stuff. And then here's the magic from ChatGPT. So it takes our gyroscopic angular acceleration from the MPU and puts it into a matrix, and then applies all these Euler transforms and approximations to it, which are super complicated, and honestly I don't understand, but they work, so it works, and I won't touch it. And it figures out the orientation of the MPU. And then we have the second one here, which takes that orientation we just calculated up here, and then it applies that to the acceleration calibration values, so that when we take the acceleration, we can subtract the calibration from it and get back to gravity being 0 when the MPU isn't moving, but when it is, this will just subtract gravity and not mess with anything else. But yeah, that is the code, man. All right, so this is the flowchart for the code of our awesome ski tracker. So first the program starts, pins are configured, there's a little intro thing displayed to the LCD, the MPU, which is the accelerometer, is connected to and calibrated, all maximum values are set to 0, and then tracking set to -1 just means it displays the LCD screen, and then recording is 0, so it means height isn't being recorded right now. So now this is all just the void setup, now we get to the actual void loop. So we get the acceleration and gyroscopic values from the MPU, then we calculate the orientation of the MPU from those values, we filter out gravity based on the orientation, and then we can calculate things like acceleration, speed, rotation, tilt, etc., etc. Then we check if the ultrasonic sensor is 10 centimeters off the ground, and if we're not recording. So that basically is checking if the skier is just jumped or not. If yes, then we start recording, we start the timer to track time, and we also record the speed at that time. And then it'll go instantly from there to recording the air time, calculating distance traveled, and recording height off the ground. And then it's going to check if the distance sensor is back on the ground. So if not, so you're still in the air, it's going to check if all the max values, and if any of these values recorded before are greater than max values, which they will be for the first loop, they'll all get updated and they'll repeatedly update as it loops through. So update the values if yes, and then we go here, and it'll ask, has the button been pushed? If not, it's just going to display whatever tracking is. So right now it's -1, so it'll show the LCD intro, but anytime the button is pressed, tracking will change, and then that'll change what is displayed on the screen. So as you can see, 0 displays acceleration, 1 is speed, 2 is jump height, 3 is jump time, 4 is jump distance, 5 is rotation, 6 is tilt, and then 7 is special. So if you hit 7 and then you wait 4 seconds, all the max values will be set back to 0. Otherwise, if you just hit the button again, it'll go back to acceleration. So all that goes back in the loop. So say we're still in the air, so this is going to be no, because yes, we're off the ground, but recording is 1. And then is recording 1? Yes, so it's going to record everything again, recalculate, and then say we get back on the ground here, so we're less than 10 centimeters. So it'll stop the timer, set recording back to 0, check the maxes, update the maxes if need be, go back to check if a button has been pressed. If yes, update tracking, and then update what is displayed on the LCD. And it'll just repeat this process forever of getting the orientation values, updating the orientation, getting all the acceleration stuff, checking if you're on the ground or not, and recording everything, updating the maxes, seeing if you've touched a button, and showing what needs to be shown based on the user preference. But yeah, it looks a little kind of funky and complicated, but it's pretty simple code. So yeah.
Now, let's take some time to analyze our mounting component in SolidWorks.
Ain't no back and forth, ain't no left or right. I got King's disease, but I move like a knight. Rappers bandwagon trying to get some light. I do it for the fam, never for the hype. When you turn a legend, no such thing as relevance. They must have forgot that I'm a new rapper that got integrity. All in the media and blogs, that's just a place I don't care to be. Most of these wouldn't say if they was ahead of me.
No back and forth, I did it back then, I do it right now. I open a lane for my era, I'm goated, they gave me the crown. Go, with all the success, come negative press, I'm watching it pow. They saying that black music dying, I'm saying they right on the south. But look at me now, damn y'all, look at me now. Whatever I do is in why, I'm keeping it Queens, cause that's my side. I shook up the town, I shook up the city, I shook up the state. I went 21 on my second run, it's with age. It's a conversation, it's determination, your interpretation. I just shocked the nation. Did my tour with the Woo, I came back and I set the pace. They just ran in, one of my crips and took what I replaced it. 2 Caucasians, so part of their faces. Most of y'all assume that they was black as exploitation. They know that I see everything invested in ring. It's cool to be mainstream, I'd rather be timeless, that's if we keep it in P. 21.
I'm on that same trajectory. Bullet wounds in jail cells couldn't stop me, this my destiny. Never controversial, I'm mad the fans expected less from me. Sneeze around me, wipe his nose, won't get no bless from me. Jury, I'd rather buy land and invest successfully. I got all type of stocks and bonds, they Wiley on my wall and I'ma pass it to my son. It's savage like the capo, that mean Escobar the Don.
Cool, we go.
One mic, one gun. My net worth like 8 figures. I'm working on getting me 9. You know that I'm one of them. I ain't doing no cap in the line. You rappers be chasing the hype. I do it and I don't be trying. I ain't going against no legend. I'm trying to be next in line. They acting like I just popped.